At the NASA Ames Research Center in Silicon Valley, scientists are developing the next generation of rovers to explore the Moon and Mars.
K10, it's a planetary rover. It's designed to allow us to explore natural terrains, and it's equipped with a number of different robot sensors and scientific instruments.
NASA's Terry Fong says the sensors make it possible for the robotic rover to see what's around it and where to drive.
To understand its environment. So we use a lot of different cameras. Up here there's a stereo pair, so a left camera and a right camera that we use to image the environment. We figure out what's safe, what's not safe, how rough is the environment. We also use on top here, this spinning sensor here is a 32-beam laser scanner. It's collecting lots and lots of 3D data in real time to allow us to figure out also how far away are rocks, how steep is a slope, and that sort of thing.
Today, scientists in a command station on the other side of the NASA campus is testing the K10 on a simulated moon surface.
There are a couple craters, there's a small hill here.
In the next couple of months, engineers plan to perform the same test from the International Space Station.
We've never had robots controlled in a fully, interactive mode from space station. So we're trying to figure out, are there any differences? Are there things that we might be surprised by? Things which we actually have to plan and then design future systems to be able to handle.
The goal, says NASA, is to make robots like the K10 ready for the next manned moon mission in 2020, where they'll use these new planetary rovers to deploy telescopes on the far side of the moon.
So it's basically like a very large ribbon cable. Okay. And you can then pull that out, you can stretch this out, create these very long runs, perhaps 50, 100-meter long antennas that you can then use for radio astronomy.
And then the robot knows to spool it back up when the experiment is finished.
Yeah, in this case, for our experiment, it'll know to spool it back up. For an actual mission to the moon, what you do is you would actually lay this out, that you would connect it up to a central electronics box, and then you have a fully functioning radio telescope array.
Fong adds, radio astronomy is one of the fundamental scientific interests for NASA going forward.
The far side of the moon is an ideal location for doing radio astronomy. It's radio quiet because you have the whole mass of the moon blocking stray, signal, where you can make observations of really the cosmic dawn. So being able to really look far, far back in time and try to understand what happened many, many billions of years ago.
In San Francisco, I'm Kara Suboy, CNET.com for CBS News.